In this segment of the video, we are going to review what happens when we vary the moles of the reactants and the moles of the products. This chemical reaction represents hydrogen combustion, where oxygen molecules interact with hydrogen molecules to form water vapor. The ratio between the oxygen molecules, hydrogen molecules, and the water molecules will remain the same. So if we double the amount of oxygen reacting, then we need to double the amount of hydrogen reacting. And therefore, we're going to get double the amount of the water vapor. So if we double the moles of oxygen and use 2 moles, then we need 4 moles of hydrogen to react with it, and then we'll get double the product. And if we double the product, normally we would get 2 moles, but then we have to double the amount. So we end up with 4 moles of the water vapor. So what would happen if we use 4 times the regular oxygen amount, and we start off with 4 moles of oxygen molecules? Then in order for the full amount of 4 moles of oxygen to react, we need 8 moles of hydrogen because we're quadrupling the amount of reactants being used. Okay, and because we increase the amount of the reactants by factor of 4, we also are going to get 4 times the usual amount of the water vapor H2O. So instead of getting 2 moles of H2O, we end up with 8 moles. Conversely, we can measure the amount of product that's been produced. So let's say we measure the amount of product, the water vapor, and it happened to be 6 moles that was produced, then we can deduce that triple the amount of the reactants was used to get 6 moles of H2O, because normally we would expect 2 moles for 1 mole of oxygen. Okay, but it's triple that, so we can correctly deduce that the amount of reactants was tripled. So we can assume that 3 moles of the oxygen molecule interacted with 6 moles of hydrogen molecules. In this segment of the video, we're going to inspect what happens to the grams of the oxygen molecule, hydrogen molecule, and water vapor during hydrogen combustion reaction. Once again, the ratios will remain the same. Here you're given a table, but you have to be very wary that the grams that are given to you, and this time G is not gas, it's grams, it's the mass of the molecules, happens to be grams per 1 mole. Okay, so the grams that are given is for only 1 mole of the molecules. In the actual reaction, 1 mole of oxygen is consumed, and that remains to be 32 grams. However, for hydrogen, 2 moles of hydrogen is consumed, so we have to double the amount that's actually in the table. So we need 4 grams of hydrogen to react with 32 grams of oxygen in order to produce the water vapor. And even with the water vapor, 2 moles of water vapor is produced, so we need to double the amount that's in the table to be able to deduce the amount of oxygen that will be produced during this reaction. And I mean water vapor, not oxygen. So water vapor, H2O, is produced, and it's 2 moles that's produced, so we have to double the amount of moles. So we should expect 36 grams of water vapor when we use 1 mole of oxygen with 2 moles of hydrogen in order to produce 2 moles of water. Okay, and also note 32 plus 4 gives you 36. So the left side and the right side of the reaction should always remain the same in terms of the total amount of grams. As in the earlier segment of the video, the ratio of the molecules need to remain the same throughout the whole reaction, regardless of how many grams we're using. So the ratio to hydrogen and water vapor should remain 4:36 in terms of grams. Okay, now the final product of the water vapor, if it's 72 grams, we just multiply the 72 grams in order to figure out how much hydrogen was actually consumed. And then we get the correct amount because the ratios need to remain the same. To answer the question regarding the amount of oxygen being consumed, the oxygen to water vapor ratio will remain the same throughout any reaction that happens to be hydrogen combustion. Okay, so the equation needs to be true for all hydrogen combustion reactions. So the ratio 32:36 will always be the same, regardless of the total amount of the product. So once again, we use the ratio for oxygen this time, oxygen to H2O ratio, and then we multiply by the total amount of the product that we got from our experiment, and then we can deduce how many grams of oxygen was actually consumed.